When I go deeper into the body, meaning that number is getting bigger, my depth is getting bigger. This is my 20. That's my 20. My frequency is a lot less. Okay? This is my 5 right here. I'm able to send out pulses a lot more often because my listening time is shorter. Okay? So remember, when you're changing your depth, you're changing the PRP and the PRF. But remember, you're just changing the listening time. This right here, pulse duration, that's already determined, right? It's already determined by the manufacturer. The different transducers. What's the only way I can change my pulse duration, guys?
Change the transducer.
Change the transducer. That's the only way I can change my pulse duration. Okay? That's why it's considered. That's why it's not considered adjustable, because there's no knob on the machine that I can do to change the time of that pulse.
When we change the PRT, we change just the listening time?
That's it.
Or the pulse?
I just said you're never changing that. You're never changing the pulse. The pulse is the pulse is the pulse. Write that down. The pulse is the pulse is the pulse. You're never changing that. You're only changing the listening time. Just this line right here, this is all you're changing. From shallow, look at them. That's the only difference. All of my pulses look exactly the same. The only difference is the space in between the pulse, that time in between the pulse. That's the only difference. That's all you're changing right there. Okay. Ooh. All right. I already talked about this. PRP and PRF are inversely related. A longer PRP results in a lower PRF. Right? A longer PRP from beginning to the beginning of the next pulse results in a longer, a less frequent PRF. Okay? So, and also again, they have a reciprocal relationship, just like period and frequency. So when I multiply those numbers together, bang, I see get 1. And I think we did pulse duration the other day. So we were trying to determine what we were doing period and frequency with reciprocals. You can do the same thing with this. All right. We're open, guys, up to this point. Pulse duration, spatial pulse length, pulse repetition period, pulse repetition frequency. Okay. We good, Mike? No questions? When? You got a question? I see your can go. Okay. Sweet. All right, let's talk about the duty factor, guys. That's the percentage or the fraction of time that the system transmits a pulse. Okay? When we're talking about duty factor, it has no units. Because we're going to use percentage, which we already learned in chapter 1. That's unitless, right? All right? So, duty factor, no units. It's like unitless.
The question here on the homework, it says, why can't the pulse duration and spatial pulse length be adjusted? Is it because it's the source?
Determined by the source. You said pulse duration and the spatial pulse rate? Yes, ma'am. Because it's determined by the source. And the pulse repetition period and pulse repetition frequency are determined by the depth as well. Okay? The maximum imaging depth. All right? So, where's my book at? I got so far. I had wrote some stuff down here I wanted to talk about. Okay. So again, we're going to either do duty factor by just the number by itself because it is unitless, or we're going to use percentage, which is also unitless, right? It has percentage is telling you the fraction or the amount of something into the whole thing. All right? Our typical values for duty factor range from 0.2% to 0.5%. Again, guys, we know that's true because we know that the ultrasound machine, go back. We're going to always have to listen a lot longer than we're going to have to transmit. Remember how short our pulse duration is? I don't have the typical units up there. We go pulse duration. Sorry for going all the way back, but our pulse duration is 0.3 to 2.0 microseconds. Okay, or a millionth of a second. We're going to have to listen a lot longer to account for that depth that the pulse is traveling and has to reflect back. Okay, so I want you guys to know that the duty factor, I'm sorry, the machine, the ultrasound system is always listening a lot longer than it's transmitting. Okay? It's always listening a lot longer, it's always waiting a lot longer than it is sending a signal out. Okay? Look at that. That's like minimum 99.8%, right? Is listening, right? It's listening almost all of the time. It's listening almost all of the time. Alright? 99.8% is listening to 99.5%. It's listening all of the time. Alright? That's determined by the sound source. Okay? Remember, the duty factor is unitless. Okay? It's going to be determined by the sound source. So, of course, when we're changing the depth, because we're changing the listening time, right? We're changing. Remember, it's the percentage of the time that the sound is transmitted versus the time is transmitting and listening. Okay, and I'll talk about that in 1 second. So, yes, it is adjustable when the technologist changes the depth.
The same as the other ones?
Not the same as the other. This one is special because it is a unitless number. That's why it says it's only determined by the sound source and not the imaging depth. But the imaging depth affects the duty factor. Okay? It affects the listening time. Okay?
But it's,
Go ahead.
it's nothing to do with like being adjusted or anything.
It is adjustable. But when we change the depth,
I mean, determined by. No, sorry, determined by.
no, not at all. Not at all. Because we're talking about just a percentage or a fraction of time that the sound is transmitted versus when it's transmitted and listened. So we're going to talk about in 1 second. I hope I cleared up after the next slide. All right? So our duty factor, that's going to be our pulse duration. Because remember, it's the fraction of time that the sound is being transmitted. Right? Pulse duration over the pulse repetition period. All right? Talk about that in 1 second. I'm coming to it. Yeah, it is the formula. Put this on there. Determined by the source. Is adjustable? Yes, because when we change the depth, we're affecting the duty factor as well. Because when you change the listening time, you're changing the percentage of the transmit time versus, or the pulse duration versus the pulse repetition period. Right? Because just look up here. Look how short our pulse repetition period is. This is, we're actually, the duty factor will be higher. I always call duty factor high related is like the working time. I always can say the transmit time is how much the machine is working. Okay? So if we're this shallow pulse right here, this duty factor is going to be higher because the pulse is, the pulse is being transmitted more often. It is working a lot more than when we visualize deeper structures. Okay, it's going to be working a lot more. Look how we transmitted a lot more times in shallow imaging than we are in deeper imaging. Okay, and you can just eyeball that and see that it's working a lot more, or it's transmitting more often. So our percentage is going to change based on that fact alone, right?
Right.
Right, guys? No?
Can you explain it
So
again?
the more the pulse is, the more the duty time.
Exactly. The duty factor is
Percentage.
just
Yeah.
the percentage of time that the system transmits a pulse. So it's the pulse duration divided by the pulse repetition period. So it's one transmit time divided by one transmit time and one off time. Okay.
Can you return to the last picture, please?
Right there. It's just showing you the relationship.
Oh.
Because all we're doing with duty factor is taking what percent is the pulse duration of the PRP? So when I change the depth, I'm gonna be changing that number, right? If I go deeper, then my listening time is gonna be a lot longer. That's gonna affect that percentage of pulse duration versus the listening time. I'm sorry, versus the pulse repetition period. Right?
So if we have the number is higher, that means we are deeper?
So I like that question. That's a good question. Let me give you guys an example. So if we're listening for a longer amount of time, then our duty factor is gonna be less because the amount of time it's transmitted is gonna be minuscule compared to the time of transmit and receive. Okay? If my pulse repetition period, if my listening time is, if it ended right here, if my listening time ended right here, say it ended right here, then my duty factor will be about 50%, right? Because my pulse is about equal to my listening time, right? So it'll be about 50%. If my pulse ended right here, I don't know. It looks like it's about a quarter of it or something like that. Maybe 4 pulses can fit in this space right here. I'm just taking a percentage of the pulse duration versus over the pulse repetition period. Was that okay explanation?
Yeah, you're just looking at the pulse.
Basically, you can almost kind of eyeball it sometimes, but it is a formula for it. All right.
Right, to find that percentage.
Absolutely. Okay. So when creating anatomic images, the duty factors are in range